Hey folks, in this video I want to discuss the keys operation. So the keys operation is one of the final ones defined in our interface for the symbol table ADT. So the purpose of this function, or this method, is to return all the keys in low to high, which is a closed interval. Okay. So basically what we're saying is we should be able to do things like this. Return keys. So let's go keys of, 2 to 5. What that should give me back out is 2, 5, 7. Okay, so I want all the keys in order within this interval, right? Starting at 2, ending with 5. So for this, this is okay. So this is not too complicated. This actually goes back to the tree traversal we talked about at the beginning of this module. What we want to do is basically just do an in-order traversal. So an in-order traversal, right, basically just puts everything in the proper order. That's the equivalent of writing out, and I'll just do it right now, right? If I did an in-order traversal, I would get this as a result. I'll get 2, 5, 7, 8, 10, right? I'll get that sequence back. Well, I'll just get that sequence back and then chop it here and here, okay, and get that back. So yeah, it's not that bad. It's not that bad. All we gotta do is do an in-order traversal. So let's take a look at the code. Code is here, all right? So I have my two ones, my recursive one, right, and then my main one, or my helper one. So my helper one, the first thing I do is I create a new queue, right? And in Java, just because of the way Java is set up, right, a queue is really a linked list, right? Queue is just an interface, linked list is the actual concrete implementation. All I really want, right, is a place to store my different values, or my different keys. So yeah, I create my little queue, right, and then I call my recursive function. And my recursive function has an argument to keep track of the part of the tree I'm exploring, right, the local root, and then the queue into which that I'm adding the different numbers as I see them. And then the low and the high, right, just kind of get passed along because I need them to. All right, so what happens in here? So this is the main block of code, right, where all the work happens. And in here, right, basically what we say, right, is that, well, if you want to list all the keys in a tree and that tree is empty, then I'm just done, right? Nothing to do. Here, right, notice that my return type is now void. I'm no longer returning a node. It's void because the work that I'm doing, right, listing off the keys, is being stored in that queue variable, right? That queue variable, there's just one of them, right? Everybody kind of sure all the recursive calls, right, are going to be pointing at that same queue variable, right? They're all going to be have references to it. That's going to be where our output is stored, right? We're not going to return anything, right? We're just going to store it into that queue. Looking down, we have what looks like an in-order traversal. So notice here, right, that I have basically, and this is maybe a little hard to see, but this is my traversal right here. So keys, right, is the function. So somehow it's like keys recursively calls itself. So notice that keys calls itself. Then it does the queue.add, right? Somehow the equivalent of like viewing the node, right? Making a node of what it saw. And then it does the recursive call again, right? So if you have recursion, visit, recursion, that's an in-order traversal right there. So yeah, we're doing an in-order traversal. And what you have here, right, basically the other part is some logic, right? Some logic to say, are we in the right area or not? Because what we don't want to do, right, is we don't need to traverse to the left when it goes out of bounds, right? We have this lower point, right? We only need to go so far. So if we go less than that, no good, not needed. If we go higher than the higher bound, again, not needed, okay? So that's what these two things are doing here, right? So we're computing high and low, right, to compare what we're looking at to our bounds. And we're seeing, are we in the bounds or not, right? Do we want to continue exploring, right? Well, we have the appropriate error. Well, the values are appropriate, right? We're going to continue, recursively calling ourselves. But instant we have the option of recursively calling ourselves on somebody that, isn't, in our interval. We're not going to, that if statement is going to be false. We're not going to end up doing that recursive call, right? We're not going to end up exploring it anymore. So this basically will take that little slice of the tree, right, to make sure that we're only seeing this part of it, right, is what that's doing, right. All of a sudden, the high one will be out of bounds, right, if we go to the right hand side, right, so it'll never make that recursive call on, for example, the 10. So that's how basically these 4 lines here work. The middle check is basically kind of an absolute one to say, oh, I'm looking at something. Are you within both of the bounds? Because sometimes, right, kind of on the way down, right, it's like, well, at some point you have to visit that one to get to the area of the tree you want to print out. And we need to verify, right, that that's not something we add to that queue. And so every time we add to that queue, we always check to see, is it what I'm looking at within that upper and lower bounds or not, right? Because if it is, right, we add it. Otherwise, who cares? And so yeah, function is basically just, at the end of the day, this is really just an in-order traversal. An in-order traversal to check with some additional checks to see that our recursive calls don't go farther to the left or farther than the right than we need to. All right, so that's the implementation of keys.